All right, good afternoon, or evening, or morning. This is Mr. Gubino. We are going to be talking about the Big Ten Riemann sums today. Uh, I went to Meyer with my mask on and got a new hat. Yeah, America. Okay. So, anyways, we're going to get started on the Big Ten, and let's get started. The Big Ten has 10 problems. You are going to cross off the numbers as you go through this. So, the Riemann sums, I'm going to put up a different Riemann sum video when we get to it because we did not do this in class and I felt a little rush trying to do these. But once I figured it out, hopefully I'm better. We have a circuit that you're going to have to do. So let's get to it. So this is my delta x. Okay. And my delta x in a Riemann sum is b minus a over n. So this is from the a to b, how many triangles do we get? Okay, so, or rectangles. So this n, as it goes to infinity, is the number, this is going to be my delta x. So my b minus a comes from these two numbers, b and a. So my delta x is 6 minus 1 over n, which is 5 over n. And if that is my delta x, c over n is equal to 5 over n. That means that c is equal to 5. So far, so good. I got that first part. Now, in here, this x cubed is going to be replaced with 1 plus bi to the over n to the third power. Well, this inside is my ci, and that ci is made up of the first term plus your k term, or in this case your b term, times I over n. So this term, or I is your k term, kind of, b over n has to be your delta x. So that's your delta x times I. So in this case, if my delta x is c over 5, that means the b is 5 as well. So in this case, 5 minus 5 is 0. We're going to cross that one out. I'm going to put an A next to it just so we know that it's right there. All right, Riemann sum, 4 equal subintervals, not necessarily equal, but 4 subintervals from 1 to 8. And then this is the left one, this is the right one. So reminder, we need 4 subintervals, so we're going to go from these 4. So the difference of those is going to be your delta x. So we get a 1, we get a 2, we get a 3, and we go back to a 1. So we have a 1, a 2, a 3, and a 1. And it's going to be the same down here. Okay. And then what we are going to do is we are going to multiply for the left one. I am going to multiply by the left one. So 4, negative 2, 1, and 5 ends up being 8. So 8 is B. Let's do the right. So the right is going to be, the right, the right, the right, to the right, to the right, times negative 2, times 1, times 5, times negative 9. And this answer, I know, comes out to be 6. So there is our C. Okay, the velocity, part D. The velocity of a particle in meters per second is given by the table. Use the left Riemann sum with 4 subintervals indicated in the table to approximate the total distance the particle travels. This is a velocity, and we want the total distance. So we need the speed. We need from 0 to 8 of the speed, which is the absolute value of v, excuse me. So I need the absolute value of this one, which is going to be 1. Because if you look at a velocity, if a velocity is negative 1, your going backwards, but your speedometer, as Mark put it in the video, is going forwards, which is going to be 1. So left, these are all your delta x's. 1, 4, 2 and 1, 1, 2, 4, and 1. So we have your delta x, and then we're going to times it by your left hand values. So your left hand values are going to be 0, 2, a half, and 1. 0, 2, a half, and 1. So here we get 0, 4, 2, and 1, which equals 7. All right. There's that one. Moving on. Here we have a graph of, let me move this like that. Here we have a graph of g, and we're asked to show which one is the greatest value that we have. So if we're looking at greatest values, we're looking at Riemann sums. So this one, from 0 to 4 of g of x, well, g of 4 of x, that's going to be everything in that thing. That is your actual. That is what we talked about. The limit as x approaches infinity, that was your actual. Okay, I'm just kind of zooming in. Let me focus it a little bit. That's okay, it makes it a little bit better. All right, the left Riemann sum intervals. So if I drew the left Riemann sum intervals, I start at the left. There is a little gap there, so I'm just going to move it over. Left to the left, and then this one goes to the left. So if you notice all these purple ones, this is a big under approximation, which is actually smaller than that one. So 2 is out. All right, the right Riemann sum, I'm going to do in green. The right Riemann sum, we go to the right points and we go to the, oh wow, we go to the right. So we have big one. The green are the big ones. This is a big over, and it knocks that one out. All right. The midpoint, well, the midpoint is going to be halfway between these green and purple ones, and the midpoint is going to be under the right one, so that one's out. This is your actual, and that's out. And the trapezoid, well, the trapezoid is pretty close to the actual. So if it's pretty close to the actual, it's going to be under that. So E is 3. So we're going to cross 3 out with E. Okay. Aha, here's the problem. All right, this is the one that I got stuck on for a little bit. We need to know what A plus B is, and it's equivalent to the expression of that. So I have that one already kind of worked out. I'm going to go over that one at the end. So I'm going to come back to that one because I need a little bit more room for that. So we're going to go to G. Okay, and when we go to G, I'm going to pause right here for a second. All right, sorry about that. I had to sneeze. So water is poured slowly into an empty glass. The height of the water measured in inches is recorded in the times tables above. Use the right with 4 sub-intervals of equal length. Now that I've sneezed, I can't talk. All right, so we need a fourth of that. So we need a fourth of this sum. Now if you notice, all of these delta x's are going to be the same. And if they're all the same, I'm just going to pull them out in front. And then all I'm going to do is add up the 4 values that I need if I'm looking at the right hand side. So I need these values. 1 plus 1.25 plus 2.75 plus 3. So I need a fourth. The sum is 1, 2, 3, 4, 5, 6, 7, 8. And a fourth of 8, basically we're looking for the average rate. And that is dos. So G in our values is going to be 2. All right, we're on our way. Last page. And then we'll come back to F. All right, the rate in hundredths of people in the park, amusement park, is changing. They want to know if there are 300 people at 12 o'clock. So the integral from r of t is going to be 300 plus 0 to 6 hours after 12 p.m. to 6 p.m. of r of t dt. Okay, so what we're going to do is we're going to do this, but we have to use the midpoint. All right, so I got my 4 colors. Use my, I don't know if these are primary. Yes, they are. I'm kidding. No, they're not. Green is not a primary. All right, 3 equal subintervals. So we're going to go to 2, we're going to go to 4, and we're going to go to 6. All right, so we got this one. We have this one. And we have this one. So what we're going to do is we're going to find those, and we're going to go to the midpoint. So the midpoint would be the average of these two, which is going to be at 1. So it's going to be this rectangle right there. The green one is going to go to the midpoint of 2 and 4, which is at 3. We're going to find that value. We're going to put a rectangle over. And then we're going to go to 5, because that's halfway between. And we're going to see that the rectangle hits right there. And we're going to look for that area. So we need the areas of each of those. Okay, so our delta x is still 2. And if our delta x is constant at 2, we just need the heights of each of these. So the height of this one would be 2. The height of this one is 1. And the height of this one, well, that's negative 2. Okay, so it's a shift of, let's see here, 2 times 1, which is 2. So 200 people is the change, or is how many people came into the park between 6 p.m. up to 6 p.m. Well, we have to include that 300ths plus 200ths is 500, or 500ths. There's your answer. So this is 400 people coming in, this is 200 people coming in, and then they're going to lose 400 people going in. If they started with 300, then we're going to add each of those little rectangles together. So that is our 5. Oops, that's not the 5. All right, so our 5 is H. We're going to get that one out of there. Use the trapezoidal. Oh, okay. Well, the trapezoidal, we could do left, right, and then take the average. That might be easier, but I want to show you the trapezoid just so you remember. So trapezoid is 1/2 base times height 1 plus height 2. Actually, I think I messed that up. That's 1/2 height to base 1 plus base 2. It doesn't matter. But these are our heights, and this is your delta x. That's your width. And if you notice, the delta x is not the same for each of those. So we have a 1, a 1, a 2, and a 2. So a trapezoid, for each one, we have a height, and then we're going to take these two and add them together. And then we're going to add the height, the second one. Let me change colors here. That'll be good. Take this height, which is 1, and then we're going to add these two together. Then we're going to take our height, which is 2, half of 2, and then we're going to add those two together. And then we're going to add, there's blue, we're going to add 1/2 of 2, and then we're going to add these two together, 0.25 and 0.75. Alright, so let's do a little bit of work here. This is 2.5, so that's 2.5. divided by 2. $2.50 in half is $1.25. We'll go with that. This is 2. Half of 1 times 2 is 1. This one is 1, and then this is 0.75. So that's going to work out. It'll work out here. This is 1, and this is 1. So plus 1, if I add those two together, I get 1, 2, 3, and then this one makes 4. So there's my answer for J, which is 4. Alright. And then we got another midpoint one. They added another midpoint one in here just for our liking. Halfway, 3 subintervals, 0 to 6. So we have the subintervals here and there. Now, this is a curve, this is a curve, this is a straight line. It doesn't say that it's a straight line, but we are going to go that it is a straight line. We can find the slope and we can approximate that value. So 1, we're going to go up to where it hits that graph. So 1 is going to be this area right there. At 3, it hits right here, so it's going to be this area right there. And here, it's going to hit halfway between, which is going to be that area right there. So when I look at those areas, all right, I still have a common delta x is 2. So I'm going to take 2, and then I'm just going to add up those 3 sums. So this is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6. And this is a half and a half, which is, I'm sorry. Let me go back. Oh, I got ahead of myself. This is 2, it's the height. This is 3, and this is negative 1/2. What I did was I already multiplied it by the 2. So I'm just going to scribble that out. And then I'm going to add those. Or I can distribute. So that's what I was planning on doing, which is 9. Okay. Which gives me my last value for K. So we're going to go back and we're going to go do number F, letter F. Yes, it is late in the evening right now. Okay, here is F. So just a little precursor to this. The limit as n approaches infinity of the summation of K equals 1 to n. And then what you will see is you will see F of this, and we can call this CI. You'll see it usually as CI, is A, which is this A, plus K, this K, and then delta X. So these two have to be the same. And then times delta X. So the delta X is the same as dx. So this function, we want to know from A to B or B to A what that value is. So in F, they gave you this, and they told you it's equivalent to this. And we had to find what A plus B is. And if you looked at the Big Ten, you know that this answer is going to be 1. But how do I get the 1? So what we have to look at is we have to look at our delta X. That's our delta X, and we're given B and A. So B minus A over N is delta X, and that is 2 minus 1 over N, which is 1 over N. So that checks out with that. Now, the next thing that we have to do is we have to decide how that 2 in there is acting. So this part right there, we have our main function part, which is this part right here, which is going to be this main function part right there. So that has to be something in there. So you would think that B was 1. However, when we're looking at this, and we would think that B was that 1, which it could be, but what I'm going to do is this isn't in A plus k delta x. This would be 1 plus k times 1 over n. That's not 1 over, that's 2 times k. So what I have to do is I have to decide what I need to do with this. This could be my 1 that I get from my a. So what I'm going to do is I'm going to factor out the 2 out of that equation. Okay, sorry about that. So what we're going to do is, since this isn't a value, what I'm going to do is I'm going to add a value to it, which I can do because it is mathematics. So what I'm going to do is I'm going to add 2. And the reason why I'm going to add 2 is this reason. If I add 2, I need to subtract 2 to get an equivalent equation of that. So what I'm going to do is I'm going to put it around that. And what I'm doing is now I am getting, if I take out a 2, I'm getting the 1 over n times the k plus 1 minus 1. So that's a minus 1. So this, instead of that value, could be that value times 1 over n, which gives me, now this is my a value, which is 1. This is my delta x times my k, which is my c sub I value that I need, but I'm going to multiply it by 2 minus 1. So what this translates into is this is 2x minus 1. So a is 2, b is negative 1, for a sum of 1. There's going to be a circuit that goes along with this. We will work with that circuit. I also posted a video where the teacher, I think it was a woman, did this problem, so she kind of explained it with that. So if there are any questions, please let me know. I'm going to post this with the answers. So let's finish out our Big 10. This is F. Yay. Okay. So there are the answers. I will post that. I will post this video, and we'll go from there. So have a good night, and I hope to see you soon.